Imagine you're looking at a single drop of water under a microscope. Now, imagine that same drop is magnified to the size of a football field. That's how small semiconductor chips are. But inside this teeny tiny space, they pack in more technology than you can fathom. Let's explore the cutting-edge tech and strategies behind these silicon microchips. At their core, semiconductor chips are made from silicon, a common element found all around us. This material has unique electrical properties that make it ideal for creating electronic components. The process of manufacturing these chips begins with a large ingot or wafer of pure silicon. Through a series of chemical and physical processes, this silicon is transformed into a thin layer called the substrate. Engineers then add impurities to create regions known as p-type positive and n-type negative, which are essential for forming transistors, the building blocks of modern electronics. These transistors can be incredibly small, with dimensions measured in micrometers or even nanometers. The precision required is so high that it's akin to placing a needle on the head of a pin from across a room. This level of detail allows engineers to create complex circuits and integrate them onto a single chip, leading to smaller, faster, and more powerful devices than ever before. As technology advances, the demand for even smaller transistors continues to grow. To achieve this, researchers are exploring new materials beyond silicon, such as graphene and IIIV compounds, which offer superior electrical properties at smaller scales. Additionally, advancements in lithography techniques allow for finer patterns on the chip surface, enabling more intricate designs without sacrificing performance or reliability. The strategy behind semiconductor manufacturing is not just about making chips smaller, but also about improving their efficiency and functionality. Engineers use sophisticated computer models to simulate how different materials and structures will behave under various conditions. This predictive modeling helps them optimize designs before any physical prototypes are created. Moreover, they employ advanced testing methods to ensure that each chip meets strict quality standards. The result is a product that not only performs better but also lasts longer, reducing the need for frequent replacements or updates. In summary, semiconductor chips represent a remarkable achievement in human ingenuity and engineering prowess. From their humble beginnings as simple silicon wafers to today's complex microchips, they have revolutionized nearly every aspect of modern life, from smartphones and computers to medical devices and aerospace technology. As we continue to push the boundaries of what is possible with these tiny marvels, it's clear that semiconductor chips will remain at the forefront of technological innovation for years to come.